Okay, welcome to this session. My name is Mika Pesonen, and I'm from our Silicon Valley office, and we are here to talk about how to develop games using Qt for Symbian devices. Before we start, does anybody know this computer from 80s? Who had this? Okay, quite many people. Who programmed that hot air balloon example using BASIC? Okay, so mostly guys were just playing with Commodore, not programming too much. Why I'm here is basically I started late 80s programming using Commodore 64, and that was one of my early graphics examples I did. And after that, I learned the Commodore 64 assembly language and did some nice graphic stuff. And ever since then, I have been doing graphics programming for several different platforms. How about this? Anybody played this game or? Hey! So I think this is when I joined Nokia 99, and my mentor was a creator of this game, Taneli Armanto. And this must be the most popular game for mobile phones. And it comes with 350 million devices, the Nokia Snake game. And I think that even beats the Angry Birds, at least at the moment. And today, our presentation is in 3 parts. First, I'm going to talk about the general problem areas, something about the Symbian hardware architecture. Then Giani Varela will continue giving some solutions to the problems and introducing their games API. And finally, Mark will, from Fish Labs, will give a nice demonstrator that uses the games APIs. And I still would like to know that how many game developers we have here that you have developed a game for, let's say, console, PC, mobile, for any platform. Okay, so quite many. How about OpenGL ES programming? Yeah, couple. So first I'm just listing the Qt-enabled platforms, and I am going to talk about what are the differences in our Nokia platforms. Then about the Qt Painter performance, some things you should know about that. And then generally Qt project files, audio stuff, and Multitouch. And finally the hardware architecture and how to optimize your OpenGL ES code. Let's start with our Nokia Qt-enabled platforms. I have here a CPU and GPU performance. So the lowest device with the weakest capabilities is the Symbian 5th edition. And as you know, notice that it doesn't come with the OpenGL ES, so there's no graphics acceleration in that set of devices. But the first Symbian device with the acceleration is the Symbian 3 and the Symbian ANA devices. For example, N8 comes with the acceleration. And it's OpenGL ES 1.1 and 2.0, but also OpenVG is supported. And then the latest devices, our Mika Nokia N8 and the Symbian Pelle are the best ones at the moment with the 1 GHz processor and great graphics performance. And if you want to know more about our device specification, now we have just updated, and those Symbian devices will include the very detailed information about the graphics accelerator that was not yet published before, but now it's available from this link. Then something about the Qt Painter performance. Here we see the different platforms. Unfortunately, I'm missing the N9 because I just got it last week, so I don't have the figures for that. But you can see that the 5th edition N97 and with the default Qt rasterization backend gives you about 7.2 million pixels per second. So it's quite slow that you cannot fill the screen many times with that kind of performance. Then I would call the black sheep in our Nokia devices is the Nokia 500 That's a special device that doesn't come with the 3D graphics acceleration, but comes with the OpenVG acceleration. And here's the performance difference, a little bit more than 3 times. You can get your bitmap performance if you use the Nokia 500 with Qt. And then comes the Nokia N8, and I have here 2 different figures. One is the Qt with the default backend, and the other one is the N8 just directly using OpenGL ES. So you can see that there's some performance difference even using the large bitmaps. Directly using the OpenGL ES is the best way. And then our new device is the Nokia 701. Comes with quite much graphics performance if you compare how much performance you get for each pixel. So it's almost like 1 gigapixels per second you can get with the OpenGL ES for those category devices, the new Belle devices. But now the interesting thing is that what happens if I just use the small, really small 8x8 bitmaps and I'm splitting those to the screen and measuring the performance. So here you should notice these. So basically, all the Qt backends, I would say, has some issues because there's always like a more than 100x difference compared to the OpenGL ES, and this is something you should be aware. So if you are splitting too many small bitmaps, there's a performance penalty for each draw call, and you cannot get much performance out of that. So what you can do here is that you can just combine those small bitmaps to bigger bitmaps and then split those, or then use OpenGL ES, which gives you the most performance you can get out of the platform. Then something about the project files. At least for Symbian, first thing you should do is that increase the heap size. Then you are not getting any unexpected crashes or anything like that. Here's a little bit, maybe too few megabytes, so you should use like maybe 50 or 60 megabytes when you start your project, and then scale that down according to whatever your needs are. But the most interesting is the last flags. So those are the vector floating point optimizations, and those does not come automatically, so you need to add that line to there, and then you get the vector floating point acceleration to your project. And what that means is that, for example, I have tested a very popular Box2D library, and it gave me like 2 to 3x performance for my physics calculations. So those are a couple of things you should remember to do for your project files. Then about Qt and audio, I think this slide is kind of self-explanatory that I wouldn't use the Qt for audio, and I can give you reasons why not. So the first one is the Qt media player. Let's say you are playbacking an audio, MP3 audio, and you have that on a certain volume level, let's say 50% of the volume. And then if you play back a second audio with the Qt media player raw audio, and if that is in the 100% audio volume level, what happens is that the MP3 will play back kind of silently, but when the raw audio will play back at the 100, suddenly also the MP3 playback goes to the 100% volume. So there are a little bit these kind of issues with the Qt media player. I think the API is not so bad, but the Symbian adaptation has some issues there. And then with the Qt audio output, one problem is the audio latency. So that is already fixed in the Symbian ANA release. Previously, before that, it was something like 500 milliseconds, so really kind of high latency. But now with the Symbian ANA, it's 150. But then I would argue this that there are still devices out without Symbian ANA and the original N8 software. So even using this is a little bit tricky.
And the second problem with the Qt audio output is that the default volume is quite low, and there's no API in Qt to change that. So that's also challenging. And there are similar issues with the Qt sound. For example, if you want to play back short looping sound and you increase the loop sizes to infinity, what happens between these loop sequences is that there will be 150 milliseconds of silence or something like that, so the looping is not working. So there are a little bit this kind of issues. Of course, if your game already works with these, then you don't have these issues, but you should be just aware that there might be some serious issues with the Qt audio implementation in Symbian. And because of that, I would recommend just use the Symbian dev sound, because with that you can get the lowest latency possible for this platform. Then about multi-touch issues. First, I would like to say that the Nokia N8, there's a hardware limitation in the Nokia N8. It comes with the dual touch hardware, but unfortunately, the hardware I would say that can only handle one finger, because if you put your two fingers there and you a little bit drag the screen, sometimes the X and Y axes flip. So because there's a hardware issue in the N8 touch controller. But with the other Symbian devices, any like E7 or the latest Pelle devices, those come with a different multi-touch hardware controller, and it means that it supports that two fingers. And possibly there's now software limitation that it's not supporting like 10 fingers, but that might change. And I mark it here like 2 fingers you can use with the green, and possibly the yellow fingers are coming in the future. Still about the multi-touch. Even though you can use the 2 fingers or even more, there's a quality issue that if you drag your screen like this, here the first finger gets all the touch points, but the second finger might miss some touch points. So there's in Symbian platform, it's a platform issue, it's not a Qt issue, that it will filter these some of the touch events away. And you should just know that this issue exists, and depending on what kind of game you are or app you are developing, you should avoid using this kind of drag gestures. Okay, now about the Symbian hardware architecture. It's a 2-chip architecture. It means that you have the ARM core there, and that's connected to the GPU. That's a different chip, and there's a host interface between these. So I would say that how you can think this is like the old school OpenGL on Unix machines, the GLX protocol. So you had the client and the server, and there was a TCP/IP connection between those two. It's similar here, but it's just inside our device. And the problem here, first problem is the N8 comes with a 32 megabytes of graphics memory, and because the UI is running and all our different operating system tasks, only 20 megabytes is available for your game or app, and that's quite a limited amount. And but the Pelle devices comes with the better hardware, and now we have 128 megabytes of graphics memory just for the graphics. And I would say that 100 megabytes is usable for your apps. And basically it means that the GPU stores the textures, VBOs, frame buffers, depth buffers, all that stuff inside the GPU's memory. And because we have this special architecture, there are 2 issues. First is the bandwidth. Of course, it's like downloading a movie from internet. If you have more bandwidth, let's say 1 gigabit versus 10 megabits, definitely you will get your stuff faster. And here I think it's around 40 megabytes per second, the bandwidth between these 2 chips. So this means that in your application startup, you should always just upload all the textures to your GPU and do not make too many updates during your rendering. And also you should use vertex buffer objects, because if you use, then the VPOs will be located in the GPU and you don't consume the precious bandwidth between these two chips. Then another thing is the latency. Like in the internet, you know that latency kills. And here, if you are using, let's say, an OpenGL ES command like GL get error, it means that the ARM will send that GL get error to the GPU side and it will come back. This introduces some latency, and because of that, your application might not perform so good if during your rendering you are using too many of these, let's say, round-trip calls like GL get error. So any call returning data, I would say that don't put inside your rendering loop. Then about graphics resource handling, the GOOM means graphics out of memory API. It's a Symbian native API, and here's some sequence how it goes. First, in the application init, you request free memory. So let's say you can request that I want to have the 20 megabytes of graphics memory, and in that case, operating system will check that if you can get that 20 megabytes of, or if any other application is already consuming that graphics memory. And in that case, it will start to kill those applications if you are requesting all the memory. And then when you go to the app running state, you can get this GOOM memory low event. That you can get, for example, if you press the camera button, it will eat like 10 megabytes of memory, and it will send you this event, and you should save your state. And during this save state, you should delete all your textures and VPOs, because then you will free all the graphics memory. And then your application goes to the post state, and during the restore state, you are just reading back the textures and fetching the VPOs. Of course, it might be a good idea here not to recompile all your shaders. That takes time, and those are not taking so much graphics memory. And then we have a nice EGL query profiling Nokia extension. With that extension, you can actually ask every frame or any time you want the amount of free graphics memory in your system. So that's a good profiling tool for your development. And then, of course, in the app exit, you should just delete everything. Then about the OpenGL shader optimizations for the latest Symbian devices, the N8 and also the Belle devices, as they use similar shader cores. These are the 4 different categories. So the first one is with the market with the green. Those are the fastest OpenGL shading language operations. So they are operations like square root and power operations and other simpler stuff like text-to-2D. But the next category, marked with here with the yellow, those are a little bit slower, almost like double slower. And those are mostly used for, let's say, lightning. You use the normalize and the distance and the length functions. And the third category here is the marked with orange, is the trigonometry functions like sin and cosine and tangent, and those are, it's not supported in the assembly level of the hardware. So because of that, it uses some Taylor series or something like that, and it takes several instructions if you are using those. So I would recommend here to use actually if you are heavily using sin or cos, just use lookup tables because texture 2D is you can have just 1D texture for the lookup tables. And definitely there's a couple of instructions here marked with red, so be aware of those. Those are running 150 times slower than the green colored instructions. And one other thing is that all the shader instructions on the precision in this hardware is 32-bit floating point, and it doesn't matter if you use a low or medium or high precision, but it's always a good idea to use the minimum precision needed for your shaders. And then one other thing is that loops. If you use loops in a GLSL setting language, all those are unrolled. And then also branching is not supported. It means that you are always executing the both branches of the if or else statements. Then how to find these performance bottlenecks? I think it would be, this figure can explain something. So first you have the application game logic running there, and you should just ignore all the OpenGL ES commands. Just don't call them, don't call your rendering. And if in this case your application does not run at 60 FPS, your application or game logic limited. It means that your physics engine is taking too much time or some other things in your application. But if your app still runs nicely around 60 FPS or even more, then you can enable all OpenGL ES commands except all the draw commands. So then you will find out that are you doing texture uploads or calling these GL get errors or stuff like that. So if in this case your application doesn't run 60 FPS, you can just check that what are the OpenGL ES commands that are a problem in your application. And the next phase, I would say that squeeze all the rendering resolution to 8x8. So you are only rendering 8x8 viewport, and then run all your draw commands. And if this case, your application is not running 60 FPS, it means that your vertex shaders are too heavy or you are pushing too much geometry. And the last stage is that have the full screen rendering. And if this case, your application is not running 60 FPS, it means that you are pushing too many pixels, you have too much overdraw in your game, you have too heavy fragment shaders, and stuff like that. So I will just use these kind of simple steps to check that what's going on in your game or application. Then we will show in the end of this demo, there's one developer.nokia.com example, EPONG. I will show it later. But just to mention that we are creating these kind of examples for developers like you, and all the source codes are available for these examples. And this is now finishing my part of the talk, and this is the only link you need to know that all these different projects, I have a couple of here, are available for you. And we are supporting S40. We have examples for S40, a couple of here even. And then QML, Qt Symbian, and also many of the projects are available for N9 and Mika.
Okay, hello everyone. My name is Giani Varela, and I work as a senior technology manager in Vancouver Games team. And I'm here to talk about some solutions to those problems that Mika mentioned. And let's start for a bit of history. So I moved to Vancouver actually to work with Engage, and when the Engage was stopped, we started to create this kind of native games API for game developers to develop games on Nokia devices. S60 is kind of complicated to use directly and so on. So we tried to create this kind of very core API set for game developers, meaning touch API, accelerometer, audio, file access, and so on and so on. And we tried to minimize the API footprint so that it's really easy for us to test. Like in Engage, there was like 46 different audio formats, and you can imagine like across all S60 devices, did all of those formats really work on all devices? No. So instead, we have only like 6 different formats, and it's way easier to validate on all devices that everything works. It got used in some games. For example, there's actually one game by Fish Labs in the Nokia N9 that uses this API, and some other projects. But we always found that the games need something outside of the core API set. So sending an SMS or launching a browser to URL for marketing or developer's web page. And so we started to investigate that could Qt be used for game development. And we talked with developers at GDC about this, and couple of years back, and they were very doubtful about validity of Qt for game development. And it comes from kind of a UI middleware background, so it wasn't very believable for them. But we anyway decided that let's go for it, and if there's some problems, let's fix them rather than whine about it. And so we created this kind of game test tool, which tries to mimic basically a game application. It tries to maximize CPU and GPU load while measuring kind of benchmark numbers, whether audio still works, or is it skipping, or are the touch latencies increased, or stuff like that. So why is the latency so important? Here I have a kind of like diagram of where all the latencies in a game-like environment comes from. So let's assume that there's a game is running on the CPU, and then there's first in the game loop, basically it runs at like 60 frames per second, for example, and for every frame it reads the current state of the input, so accelerometers, touch, and those kind of things. And those have natively some latency from the hardware, and also from the fact that the event loop is not getting runtime all the time because the game is running. When the game loop gets those inputs, then it updates the game state, so whether there's explosions or objects colliding or stuff like that, and then decides how to render it. This goes through OpenGL ES to the GPU, and if it's running at 60 frames per second, basically the display pipeline normally in OpenGL ES is double buffered, so it means that the delay from actually rendering any calls to them ending in screen is somewhere between 16 to 33 milliseconds. Of course, if you have a lower frame rate, the delay is going to be longer. The audio is also rendered from the game state, and the audio system has some latency. And ideally, I mean, obviously, it would be nice if these two would match as closely as possible. So when there's an explosion on the screen, there's also explosion on the headphones, speakers. But it's not actually that close even when you actually measure those. Here are some measurement numbers from the tests and for N8 and N9. One of the things we found out was that, for example, we have this test that tests accelerometer to the screen latency. The latency is pretty much infinite, or used to be infinite for the accelerometer on top of Qt when we started testing, when the CPU was loaded heavily. When it wasn't loaded, all good, latency value is low, but when you load CPU, it goes to like 5 or 6 seconds and keeps growing. We helped the Qt mobility guys to fix this, and in the more later releases, you can get numbers like 19, which is very low for this value. Although there's some actually about these numbers, there's some like human errors in these numbers because it's a human test case. So take those with the kind of a bit of error room. Then other thing we found out was that touch to audio latency was, like Mika said, like about 500 milliseconds, which is really not usable for games. So if you tap on the screen, the explosion happens like half a second later. So it's pretty bad. And other things to mention here is that well, these Mika also mentioned, but the graphics memory and the performance difference between the devices can sometimes be quite big. So you have to kind of, if you want to run on all of devices, you have to go for the lowest common denominator, I guess. So Mika also mentioned these. So the latency is a problem, and there's no volume control for the Q audio output. So we created this kind of Qgame PCM Audio API, which is a Qtified version of the Games API, native audio API. It's a static library. So it's not part of Qt or Qt Mobility. It gets linked to the game itself and shipped with the game. It's a very simple, low latency, raw PCM audio API with callback interface. It has the volume control, and it has 16-bit PCM formats, 3 mono and 3 stereo formats. It works from a high priority thread. So basically, if you're doing some audio processing, you have to synchronize it with the game main thread a little bit. That that's the downside, kind of. But the upside is that if the game loop gets delayed, so suddenly there's a frame rate dip, the audio still runs and it won't underrun. So it's a kind of I think it's kind of a good balance between how the audio should work in this case. So here's how you use it. You basically just call this static create function with the observer and the format that you want to use. You call start on the created class, and then you start getting audio events, the buffer fill events. You can also call the volume and stuff like that, but this is the basic setup, really simple and gets to the point. Mika mentioned also about the stuff with the graphics, mainly the GOOM and other things, and we decided to create another API for that and to simplify the process for developers. It's called Qt OpenGL ES2. It's a Qtified version of the graphics API from the games API again, and it's a static library. And it handles the GOOM automatically, so it requests the memory, graphics memory, and all those things. It goes to the platform GL directly, so it goes actually outside of Qt. It doesn't use Qt for the GL. It has scaling support, so you can basically, if you have original iPhone content or something like that, and you can select the iPhone resolution and it will scale it up automatically for you if you have no money to make the full resolution port or something like that. Beware though that there's a performance penalty for doing this because it's going through off screen. And there's a kind of a GL wrapping layer for debug functionalities, and I guess this is the kind of I think besides GOOM, this is another big functionality of this API. So you can add basically a kind of debug breakpoints, which in Qt Creator, and when there's some error case that, let's say that the GL error or you hit some corner case with the GL driver that may cause rendering artifacts in that breakpoint will hit, and then you can debug what went wrong in your code. And these debug features can be turned on and off with a single line statements from your project files. So it's really simple to use, and otherwise it's all automated. It uses C++ namespace tricks to control this. And for release builds, you disable all these features, and then the GL calls will go directly to the GL driver. So it's really easy to just get the fastest performance for the release builds. It also has this functionality called VBO and texture shadowing. And what it basically does is that when there's a texture or VBO upload through the API, if this shadowing feature is enabled, it creates copies of textures and VBOs to RAM, and then it uploads those to the graphics RAM as a normal GL texture upload. And we do this for the reason that in some case the developers might not want to handle those releasing of graphics resources and then returning those on their own. So this is just like you add one line to the project file and it's all handled for you automatically. There's a performance cost, of course, because these need to be copied to the RAM and also RAM increase, but it's really simple to use. We don't do anything about shaders because we could keep copies of the shader source code and then recompile them when we come back from the focus lost. But in some cases, if you have lots of shaders, it could take like tens of seconds to do, so it's not a really nice for the user. And also FBOs for performance reasons, those need to be handled by the developer still because, if you use FBOs for like a render to texture or something like that during the frame loop, it's going to be really expensive to read those back to the RAM like for every frame, killing the frame rate totally. There's some additional features, but I'm not going to go through all of them. It basically explains like what kind of debug features there are and with this API, but I'll just highlight a few. For example, there's like that graphics memory usage tracking that actually in S6 it uses the EGL extension for it, the Nokia extension that Mika mentioned. So you can just see from the debug output that how much graphics memory you are using. And those error cases that it's tracking, this is just like some of the list error cases, and the list is growing. But for example, one of them is it tracks VBO out of bound accesses. So let's say that you create a 100 kilobyte VBO, and then in the GL call you draw too many vertices and you access outside of the VBO. OpenGL ES specification just says that this is undefined behavior. It's, you know, what it might be whatever garbage is there after the VBO might get rendered, or, you know, you change a different version of the driver, suddenly, you know, funny triangles come to screen. So this kind of can be used to prune out those kind of problems in your code. There's some features that we are working with. There's QKM OpenGL ES1.1 coming as well for some 1.1 content, let's say from original iPhone game titles and things like that. And this kind of emulation layer of OpenGL ES1.1, because the N8 drivers and the other Symbian 3 device OpenGL ES1.1 drivers, there's quite a few bugs in them because it's not the main API that gets exercised anymore for graphics. So we have this kind of implementation as well for the developers who are working, who want to get their 1.1 content across. Some performance warning things are coming as well, and in the end, one day the shader portability validator that tries to verify, like, analyze the shader source code itself for things that might not work on all devices or might work really slowly. For example, the list that Mika had, like, provide you information that this is really slow shader, now consider changing. Oops. So just a quick example of how you use the API. The same kind of pattern, pretty much. You create the instance. You get the configuration count of how many render configurations there are. You loop through over them. You get the render configuration for each of those configurations by an index. And then you check the render configuration, whether it matches your need. In this example, I just checked that it has 8 bits of stencil buffer, stencil bits, but usually you would check for more things like depth buffering and stuff like that. And then you break out of the loop when you match whatever your needs are. Same for the screen configuration. And here you basically go over predefined resolutions, and there's quite a few of them, like QVGA, half VGA, VGA, NHD, wide VGA, all kinds of formats, and portrait and landscape versions of them. And like I said, if you use a smaller resolution, they will get scaled up. So let's say you pick quarter VGA, it will get scaled up. And then you can also choose the native resolution if you want. Then you basically call just the initialize function with the render configuration that you chose and the screen configuration that you chose. And now you are basically ready to call GL calls if you want to, like the basic frame rendering. But here's this additional function that you can use, which is called register assert. This will be used for a debug breakpoint if you're interested in debugging. And yes, then there's a swap buffers call as well for swapping the frames after you rendered. There's also a swap interval call for changing the swap interval if you know what that means. But it might not work on all devices. Like I think N8 only has swap interval of 1, and on A60, at least 1, 2, and 3 are supported. Here's how you basically, just examples, like here's how you enable shadowing the profile, and here's how you enable the debug functionalities. So it's really simple to turn on and off from the profile. Okay, now I have a quick demonstration of the actual debug layer in how it works, and then we'll switch to Mark's presentation. So here I have the assert function that I mentioned that you register for the API, and I have set the breakpoint here for the debug error cases. And okay, let's see, hopefully everything works. I'm just gonna start the, I have this small GL application here, which it's nothing fancy, it just renders a couple of triangles, but at certain frame, this is my test case, so it introduces kind of error conditions. And what you can see from here is that in the application window, I have enabled GL call tracing as well, so you can see all GL calls that are going through the driver. And at the end of it, you see that I'm trying to get attribute location for this attribute called pygmy projects. and there's no such thing in the shader. So here's the error from the debug layer saying that there's no such attribute found. There's no GL error for this, but the attribute location getter actually can return kind of error types, but it's still, in some cases, I find that people are not checking those return values. And let's see a bit further. So similar thing, I have a test case for getting unknown uniform location. Here's another thing. You have a GL-enabled GL texture 2D, which is not supported for OpenGL ES 2.0, obviously. And what you can do here is that you can go to you can go through the stack trace and you can see where exactly that call was that created the error. So this particular line in your code had the error, and you can inspect your variables. Like here, it was frame 250. You can check like which object you were rendering, what the state was, and all those kind of things. It's a really useful tool for debugging. There's some other things here. I won't go through all of them, but for example, this one checks for whether the floating point data in texture array, vertex arrays has correct numbers. Like this one has a subnormal number. Now there's a nan in the array or an inf, and it breaks all the time on these kind of cases. So, you know, the results of, for example, inf are totally undefined by GL spec. So whatever might render if you have inf, this one driver or one driver version, something comes, and then come a new driver version and something other comes. So it's really useful for debugging those stuff. Anyway, I'll stop talking now and let Mark come show his stuff.
All right. Hello, everybody. So my name is Mark Hehmayer. Thank you, Jani, for sending me over here, and to Nokia guys. I'm the CTO of Fish Labs. Fish Labs is a game developer located in Hamburg, in Germany. And we are mainly focusing for 7 years now on bringing rich 3D titles to the mobile platform. And of course, we have a long relationship with Nokia. And today, I'm proud to present that we are bringing Galaxy on Fire 2, which is our best-selling IP currently out there, to the Symbian 3 platform with the help of the Qt Game Enabler API. So maybe some of you guys had luck yesterday to get an N9 and maybe have seen that Galaxy on Fire 2 is preloaded on it. It's globally preloaded on the N9. So some of you guys have tested out. And for those guys who weren't lucky, I just wanted to say, OK, what is Galaxy on Fire? So actually, these screenshots you see, I made right out of the Symbian 3 build I made for this presentation. So this is actually gameplay footage running on a Nokia device. So this is marketing stuff. You can read it out, but it's more or less when you think about freelancer, privateer, elite, and something like that. When you have played it in the past. We love to play these kind of games back these days, and we saw that on mobile phone there is a lack of space simulating, space shooting games out there, and we thought, okay, we want to play this type of games on our mobile devices and maybe other guys as well, and so we decided to bring it over. We started 2005 with the first iteration of Galaxy on Fire 1 on Java. We were starting on Java. And now, 3 years ago, we bring it all over to the native platform with everything with shader support. And now we are finally there to bring it also on the Symbian 3 platform. So, Symbian 3. So, why to port over? So, why do you should care about Symbian 3 devices? Because there are millions of devices out there. So there's a huge opportunity for you to sell out to millions of users there your games or your apps to these kind of devices. I just named here a few of them. And the beauty of this is all these devices have similar specs. So of course the GPU differs now in the newest devices, but the screen resolutions are on these devices all the same. So when you are more or less not so heavy on performance, you have one build and it will run on all these devices, and there are millions out of them. And the second more interesting part is because there are users who download actual stuff from the Ovi store. So they are not only having these kind of devices, but they are actually buying stuff from the Ovi store. So there's a business opportunity here. I grabbed this slide from a website. It's official figures from Nokia. And you see here the daily downloads figures currently or in the past 1 year or something like that. And you see a tremendous growth here. So, and it won't stop. So you see not even are 1 million devices out there, but there are a lot of people downloading stuff from the Ovi store. And there's a huge opportunity that these guys will pick up your game or your app and pay for that. So what is normally our task when we bring our games to a new operating system or a new platform? And I wanted to say this in comparison to what we had to do when we target now the Symbian 3 platform with the Qt Enabler game API. So first of all, it's a framework. We have to adapt the framework to see what kind of operating system there is, to adapt some kind of things to this operating system. The beauty now it's with the Qt, it's a cross-platform solution, and we don't have to really think about it, whether it's a Symbian or whether it's a Migo device. We have this one entry point, and we don't have to really think about the OS. And like I said, Galaxy on Fire 2 nowadays is shader-based, but before that we had a fixed function solution in place, and this is, like Jani said earlier, it's just a couple of lines to establish 1.x or 2.0 context with the Qt Game Enabler API. The next thing is, of course, controls. So what kind of controls does the device have? Does it have tilt control? Does it have touch, multi-touch control, and so on? Or other fancy controls like dedicated gaming buttons or something like that. So this is something we have also to do, but this is also very easily handled in the Games API. It's the touch called getting via an event class, and the tilt values are via an easy function call, and you get the values back. Now we come to a point where we talk about graphics, so it's all about textures. So you have to think about, okay, how much texture you can use. Mika and Jani mentioned it earlier, that how much GPU RAM you have, so you have to keep in mind how many textures you can allocate and so on. And of course, how many polygons you can render, so before you drop down the performance. This is something the game developer has still to do, because this is something the Games API can't handle for you. So this is something you have to do as well. And of course, sound. Sound is also a big issue on all platforms, whether there's how many layers of sound you can use and so on. And like Jani and Mika mentioned, there's also a very elegant way to address this issue. You have now a low latency API for effects. Currently, we are using QMedia Player still for the streaming, but maybe this will change in the future. But it's very easy to bring over the sound API. So with this kind of Games API in place, we could really have the same source code and the same graphical assets you have seen, or maybe you see on the N9 on the Symbian 3 platform. So it's really the same code base. So just to summarize, the Qt Game Enabler is a very great API to reduce porting time. Normally, you have really spent a lot of work to evaluate the new operating system or the new devices, what is there. So this will all be handled by the Qt game enabler, so it really reduces the porting time. And like Mika and Jani also mentioned, there's also source code example included, and this is a great way to see how this how do you enable this games API, how do you make function calls and so on. And for us, before this, we had Symbian, of course, also in our pipeline, but we had to use Carbide. I don't know whether you guys know about Carbide. It's an IDE formerly known as the main IDE for Symbian development, and it was very outdated. And now with Qt Creator, we have a lot more, a lot more pleasure to work on it. And of course, when you talk about Carbide, in the past, when you have to make some changes to your project, there are a lot of changes in additional, in a lot of files you have made. Now it's only just a quick project change in the project file, and then you are ready to go. With all that, it took me only 3 days for the first playable to bring it over to the Symbian 3 platform, so a very efficient way, thanks to that. And what is really, what comes to this is that this is the main reason why we port Gov2 in-house to the Symbian platform. Before that, we really thought about, okay, do we have the manpower to bring it over to Symbian 3? And we thought about, okay, outsource it to some other developers who made this kind of approach. But now with this short turnaround time, we are really thinking, okay, now we can do it in-house, and that is why we hopefully, in this year, we can bring it over to the Ovi store and the Symbian 3 platform. So what I wanted to showcase is that here is just my contact and whether you can follow us on Fish Labs. And I wanted to showcase you the game on the 701 device, so you can see what it's looked like. Oops. Okay, there's still no icon, so sorry for that. So there's also sound and music in place. So this is the hangar where you can equip your ship and get freelance mission, or can hang around in space launches, talk to people, and progress in the storyline. And when you are done equipping your ships, you can say, okay, now I want to fly out. So, yeah, like I said, it's a rich 3D graphics, it's shader support, and you can shoot everything up and, say, all right, maybe there are just friendly units out there, maybe I can say hello to them.
Unauthorized use of weapons. Eliminate the target.
Now I'm in big trouble. So you see what kind of gameplay this is like. Now I'm really screwed. So this is something. All right. All right. Okay. So if you have the luck to have an N9, you can try it out on your device, maybe on the fly back home, and to see what kind of game it is. And when you have a Symbian 3 device, then you might see it in the Ovi store at the end of the tier. So thank you. So.
I wanted to ask, what should we use to enable low latency audio on the N9?
Well, I guess basically the API that we provide, the Qt game PCM Audio, that gives a fairly low latency audio, like I don't know, 150 milliseconds or so. That I don't know if you can get any lower than that in S60 currently. Even though you do native, it's about the same. So you can use either that or do the dev sound, like Mika said. but the Q audio output, at least on the original N8, will give you like 500 millisecond latency, so it won't work for you.
Okay, thank you.
Actually, before we go, and we can have more questions, of course. If you're interested in getting access to these game APIs, can you please come here and leave your card? We will add you to the release mailing list. We will have those in the eventually in the developernokia.com, the link that Mika provided, but we are currently in beta, so like Mark and their company is working with us already, so if you want to have access, just come here.
More questions? And this is the EPON game, full source code is available from developer.nokia.com/games.
Okay, so if I got it right, it's not inside the Qt project right now, so it's a separate project. So how about the license? So for example, if I would like to build a game on top of this platform and then publish, what license it has?
License, actually interesting. Mark, you know, like, give me money. No, actually, the intention, anyways, I have to clarify that. But the intention is anyway that, you know, if you're developing with these APIs, you can use it for free, and we are not interested in any. Like, we just want to actually get cool games to Nokia devices, and this is our primary mission. So we are not to make money out of this or anything. So it's freely usable. Although I had to say that it's a binary release as a static library, so there's no, it's not Qt component as such, so it's not open source or anything like that. You're welcome.
It'd be interesting to hear something about QML. Have you any experience how to do games in QML and the performance?
I think you can do simple games with QML, definitely. But we were here focusing mostly on that, let's say, you have an iPhone game, Android games, and you can create cross-platform, iPhone, Android, Symbian, Mika, whatever. Then I think the only choice is C, C++, OpenGL ES. But definitely Qt and Qt Quick and QML and 3D, you can create simple games. And we already have some examples on our developer.nokia.com/games. But we are mostly getting first this native stuff ready and available, and then focus on the future with Qt QML.
Okay.
More questions?
I have a question regarding payment for games, because seemingly free-to-play and in-game purchases seem very popular for game developers.
Yeah.
I think it's also the same way Galaxy on Fire works on Android. Is it possible for Symbian too?
Yeah, this is really good question, and I think we had an in-app purchase presentation here. But the in-app purchase API is pretty close to open beta, so not far away from here. So that is also available from developer.nokia.com/IAP. Then the source code and the SDK will come there. So it's really close. So you can easily incorporate. You can publish your game free and then have these in-app purchase items. And we have already full examples also how to use the in-app purchase, but it's not publicly available yet, but it will be really soon.
Okay, thank you.
And I just can tell that we are planning to do this with Galaxy on Fire 2 as well on the Symbian platform, so that you have a trial before you buy version, so that you can have the first solar system for free, and then via in-app purchase unlock the full game. Yeah.
We still have time for a couple of questions.
A somewhat silly but and very specific question. Was it a design decision to have the motion blur on the paddles in front of the paddle?
Yeah, it's a graphics effect. It's not a.
It's deliberate.
We wanted to have that kind of
all right.
effect there.
Looking into the future of the
and the idea here in the EPON game.
It looked kind of funny.
Okay. So ideally in the EPONG game was not to create a super cool 3D game. Just an example that shows you how to playback audio, mix audio, do the project files, all that stuff.
Oh yeah, just a random question.
Yeah. But good question. And the funny thing here, one example is that when you type your, this is the native Mika Q input dialog or something like that. It looks like from 80s or something like that. But definitely we are going to fix this, try to use the QML. But you can have the virtual keyboard here.
Okay, so I have another question regarding the portability, because you mentioned before that it is possible to write code once and also build it for Android and iOS. Is this already possible, or is this future?
For us, for the EPONG project, you would need to do the one adaptation for iOS and Android by yourself. But the game logic is just C++. So we are not, as Nokia, supporting those platforms. But it's easy. It would be easy to just port this stuff.
What I can tell, like I said, we have Galaxy on Fire 2 now running on all major platforms, except Windows Phone 7, but there's another story. And it's always the same source code. So we share the same source code. The only thing we had to do is the framework I said in one of my slides. That is the framework we had to adapt. So, but 95% of the code are the same.
Okay, but I heard that there are legal issues to make GUIs on iOS using Qt. Is this true?
So maybe.
So do you sell it over the market?
Maybe I can clarify a little bit. Like typically the game developers, like Fish Labs, they have their own almost like a OS abstraction layer, the framework, which they write their game on top of, and the game code never sees anything like Qt or Qt GUIs or stuff like that. They just port the abstraction to different platforms, and what has happened here is that Mark has ported that abstraction on top of these game enablers and Qt. So I guess what you were basically meaning is that the portability is there between, or because that the Android and iOS and this Qt solution is there because in case you have that portability solution already in place. If you have a native iOS game or Android game and you try to port that over, that's of course more work. Or if you have native Qt game and you didn't think of this portability in the first place, then you have more work also to go to Android and iOS native. We weren't saying that, like you're right, Qt on Android or iOS might have certain licensing issues with Qt. So I would certainly, like if I was a business, developing games, I would do the same, this porting layer solution instead of, because the API footprint, what the games need is fairly small from platform. There's like audio, touch, graphics, stuff like that, and it's not very wide API that you need.
So if I understood you right, you have on top of your gaming enabler Qt library, you have another Rebel library, and you don't use the Qt enabler on iOS?
That's right. So when we're talking about iOS or Android, you can't use this Qt game enabler because the Qt game enabler is just currently only for the Mika and for the Symbian platform. So, well, like Jani said, for example, Galaxy on Fire, the game as such doesn't use any Qt stuff. So everything is handled with pure OpenGL and inside our own engine.
Then the last part of my question regarding portability, does the Qt enabler work on desktops like Linux and Windows?
Actually, right now we are not really focusing it like heavily, but actually the Qt game OpenGL ES2, previously I had the build of it, and it still might work. I have to try it out if there's important customers for that. It actually works on Linux, Mac, and PC as well. And how it does that is that it basically emulates OpenGL ES2 on top of desktop OpenGL 2. So you can also run the same code. And so in some cases, this might be actually interesting and important for the developers. Like you have a game that runs on mobile and you want to have like a free desktop version or something like that, that you know, like then link to your mobile version too. But we haven't seen that used yet. But the code is definitely there. If it becomes more important, we have to make sure that that one works as well. More questions? Thank you.